For geometry, Unit 4, we're going to be talking about midpoints and segment bisectors throughout the unit. We've done a little bit of this in the last unit, but we're going to extend our ideas that we had already picked up. We start out with this unit with a definition of geometry, gives you a little paragraph here, talks about geometry coming from the word earth and metron, which means to measure. So basically, geometry should be the study of measuring things on the earth. Basic geometry talks about relationships, properties, and measurement of points, lines, shapes, and where they sit or their position in space. A lot of times geometry is used in careers such as architecture, interior design, and carpentry, but a basic understanding of geometry is also necessary for many other kinds of work. The first word we're going to talk about today is a point. And one of the things that you need to know is that a point really is determining a location. It's kind of more like what you would see on a map where there's a little dot that represents, let's say, where East Amherst is. For our purposes, our point has no width, thickness, or length. It's just identifying the location that's underneath it. So even though you make a point bigger than the person sitting next to you, it does not imply that it's taking up more space. It's just identifying a location. The other thing that you need to know is that we only use capital letters when we're naming a point. So in this particular case where you see point P, that is a capital P that's naming it. If I was talking about point A, I would use a capital A. For those of you that think that the A's are interchangeable and you write a lowercase a, if I see that on your paper, I'm going to come by and mark that wrong. You cannot use a lowercase letter. The second thing we're going to talk about is a line. And a line is technically made up of a bunch of points that all sit next to each other that extend indefinitely along a straight line in both directions. Because each point that makes it up doesn't have a width or a length or a thickness, neither does this line. The length is infinite. It goes forever because of the arrows on the end. On this particular line, you can see you have points A, B, and C that have been identified for you. There's really an infinite number of points that are sitting on that line. It's just that those are the only three that the person who wrote this intends to talk about. So if I'm naming this line, I use two capital letters representing 2 points that are on the line, and I put a line symbol over the top of it. The arrows indicate it goes forever. I could also call this line BC, and it's the same line. It's the straight line that passes through points B and C. I could also call it AC. The order of the points does not matter, so I could also call this line BA instead of AB, and the same thing for this and the same thing for this, where I could reverse the letters. The third thing that we need to talk about is a line segment, and that is going to be part of a straight line. A line segment can be measured as far as how long it is because it has a definite starting point and ending point. I use two capital letters to name this as well. So I would name this line segment DE, and again, the order doesn't matter, so you could call it line segment ED as well. When we get to the array is a little bit more specific. It's part of a line in that it goes forever in one direction, but it does have one end point. So it's sort of half of a line segment and half of a line. The end point in this picture is point G, and we can see that the array starts at point G and keeps going and passes through F, continuously going to the left. When I name this array, it is also named with two letters. The end point must go first, followed by the letter of the point it passes through, and it is drawn with a symbol just like you think. It has a ray symbol. G has to be the end point going first. F is the other point that it passes through. Quick little reminder of some things that you're supposed to know. If you are given the coordinates of a point, and they're in this form, in parentheses, as most points are, You are supposed to know that the first point is the x-coordinate, and first coordinate is the x-coordinate, and it tells you how you move left or right. The second one is the y-coordinate, and it tells you how you move up or down. So when you graph, you always move from 0, 0, the direction it tells you. So my x direction here is going to be left 3. My y direction here is going to be up 4. So my point, give or take a little bit, is going to be right here, the point -3, 4. When they ask you the quadrant that it's in, it is absolutely essential that you know that your quadrants, despite what you see on this paper, have to be written in Roman numerals. So quadrant 1, 2, 3, or 4, we use the Roman numerals to represent them. So when I'm asked in the first question, what quadrant is the point in, I would respond and say that it is in quadrant 2. In the next section, they're asking me to graph two different things. You will see, because of this notation, I am graphing a line. In the second one, because of this notation, I am graphing a line segment. And in the last one, because of this notation, I am graphing a ray. So what I'm graphing in each of these changes. So for the first question, I need to plot the point -2, 4, and that point is called A. I need to plot the point 3, -2, and that point is called B. And I am going to draw a line connecting these two. So when I draw a line connecting these two, I'm going to line my ruler up, make sure that it passes through A and through B. Go back, draw the straight line. It is a line, so there are arrows on the end. When they say name its length, it is infinite. It goes forever. When they say name its width, there isn't one. There is no width to that line. It is made up of points that have no width, therefore the line itself has no width. In the second question, I'm going to graph CD. C is the point 1, 3. D is the point 1, -5. In this particular case, I'm asked to graph the segment that goes from C to D. I'm going to draw that segment in. I'm only drawing from C to D. It does not extend past CD. When they're asking me what its length is, I can count the squares. So from C, there's 1, 2, 3, 4, 5, 6, 7, 8. For its width, there is none. In the next question for EF, I'm going to plot those 2 points. I'm going to plot the point 3, 4, which is E, -2, -2, which is F, and this is a ray. The first letter that you see under the ray symbol is the end point. The other one is the letter that your ray is going to pass through. It gives you the direction that you're traveling, if you want to look at it that way. So here's my ray. I have to remember to make sure that I start at the one point and continue through the other. So when I graph my ray, it looks like this. Its length is infinite also, because it goes forever through point F, continuing forever. And as far as its width is concerned, there is none. It's made up of a set of points all lined up next to each other. They have no width, therefore your ray has no width. Kind of a little different concept for you to understand. In the next part, it says when there is no symbol over the letters and you see something written just like this, it means the length of the segment from A to B, or the distance from A to B. So in this particular case, when they're asking me the length of AB, I'm looking to see how far of a distance it is from A to B. Direction doesn't matter. A to B or B to A is still 2 units. When they ask me to add that to the distance from E to F, if I was to count that, I would have 4 units, giving me a total of 6 units if I was to put those together. So it's very important that you remember when there's no symbol over it, there's a numerical answer. As we did in the last unit, we learned a concept and then we went on and talked about constructions with it. The construction that we're going to be working on today is how to copy a line segment. Line segments have a definite beginning and end, therefore we can make a new segment that's the exact same size. Step number 1 says to draw a new line segment longer than the original one. So I'm going to go ahead and draw one longer than what I see with MN. And then what I'm going to do is I'm going to take my compass and put it at one of the endpoints, and then open it so that it reaches over to the other endpoint. And once I get it lined up with the other endpoint, I'm going to make a mark that says I measured in this segment is this long. And then I'm going to take my compass and I'm going to move over to the end point that I have sitting at the end of my new line segment. I'm going to line my compass point up with that. And I'm going to take my compass and I'm going to mark this off, saying that my new segment has the same exact length as the old one. Now, you will notice I'm not using my ruler to measure the length of the segment. I'm using my compass to mark off the exact same measurement. Theoretically, this should be M prime, and this should be N prime, the new endpoints of your segment, which means that however big MN is, M prime, N prime is exactly the same size. We can take that idea and make it stretch a little further by looking at a question like number 7, where our new segment should be twice as long as the old one. My process begins just the same. I'm going to do a segment that appears to be twice as long as the original. I'm going to take my compass and I'm going to go over to one of the endpoints. And I'm going to line my compass a point up, pencil point up at the end so I can clearly see exactly how long my segment is. I'm going to make an arc mark that says I measured it and it's this long. And then I'm going to move my compass over to the end point on the segment that I've created, and I'm going to mark off that exact measurement. The only thing is that that represents one measurement from P to R of the original. Then I have to take my compass and move it up and now make that mark again so that from beginning to end, my segment is twice as long as the one that's there. This should be a very easy construction. We've talked about that before, how some of our constructions are very easy. This is one of those. If it said to make your new segment 4 times as long, you would do that same thing, but you would mark out 4 marks of the original. For question 8 and 9 both have a little note there that indicates that you are supposed to draw a picture if one is not provided. So they're telling me that we have a line segment that goes from A to B. And this is not a construction. It's just a quick sketch. And it says C sits somewhere on the segment that goes from A to B. We have to place C somewhere. If we read ahead, we know that from A to C is 6 and from A to B is 17. So C is going to be somewhere closer to A, so that the first part is 6 and the whole thing is 17, and they're asking us to find the missing part. So what they're really asking us to find is the part that goes from here to here. Using a little common sense, we know that if the whole entire thing is 17 and we use up 6 for the first portion of it, that 17 minus 6 is going to leave us 11 for the missing part. Seems very easy and very much common sense. We just need to make sure that you can draw that picture and understand what's happening. Question 9 is very similar. They again tell us that we have a line segment called AB. They tell us that C sits somewhere on it. I would refrain from making it look like it's sitting in the middle because it may not be smack dab in the middle. They tell us that AC is 2x, BC is x minus 8, and that the whole thing is x plus 12. If that's the case, we're going to use the idea that we've talked about previously, that one part plus the other part has to equal the whole thing. And if you want, you could write down part 1 plus part 2 equals the whole thing. So this is 2x plus x minus 8 equals x plus 12. The two parts added together. If I go through and start solving this, I get 3x minus 8 equals x plus 12, which means 2x is 20 and x is 10. Be careful, in this question they did tell us to solve for x. Sometimes though they may want you to go back and answer things like how big is AC, and you have to substitute in. How big is BC, and you have to substitute in. How big is AB, and you have to substitute in. So don't be surprised if you need to go back and do some substituting to answer their question. That was not the case here. This was our answer, but you may need to go back and do that.